So I'd like to welcome everyone to this month's ReproNim webinar. We'll be hearing from Yarek on reproducible execution of data collection and processing. So I guess without further ado, I'm going to turn the screen share over to Yarek for his presentation.
I think everybody in the audience already familiar with my face. So I will stop. I will not present myself, know where I'm coming from. The URL for the slides, if you want to get a copy for yourself, I'll paste it to the chat. So you could follow at your own speed. And in this talk, I'll be presenting the work not only of ours, but of many people. And I thought to paste everybody's photo, but I decided to say that everybody is Master Yoda in the audience, and whoever's efforts we are reusing their Yoda of their kind as well. And of course, I want to thank all those people in the agencies who shared funds to make this work possible. And we want to talk about reproducible execution, right? And you've seen this slide, which summarizes spectrum of reproducibility. That it's not even clear definition what being reproducible means. There could be, of course, original study, which, given the data and analysis, gives us results. And there could be attempts at re-execution, right, where you take exactly the same data, exactly the same analysis, and hopefully get exactly the same result, which is already non-trivial. And of course, the ultimate reproducibility or replicability, actually I forgot the difference between the terms, but another type of reproducibility which generalizes across not only different data sets, which might be nominally similar, but also maybe across different pipelines, which supposed to do the same thing. So it should generalize across analysis, or ideally, it should generalize across the data and across analysis. So altogether, reproducible execution really touches upon many aspects. It's not just re-execution. Re-execution is just part of it. We need sometimes exactly the same or similar data, right? Or we need exactly the same or similar analysis. So how could we achieve that? And in principle, actually, reproducible execution is pertinent or useful to the original study as well. Rarely any study goes just linearly, number of steps. We need to re-execute, adjust parameters, figure out how to filter the data better, how to QA it. Maybe we just get additional data sets. So this re-execution is actually present in every original study as well. And it happened that our ultimate goal, although I'm kind of, this opinion reflects, not necessarily reflects opinion of everybody, right? Ultimate goal, besides many of our endeavors, is that reproducibility itself should become just merely a feature, if not a side effect of the results, right? So whenever we have our original study, we should design it in such a way that by design, we could reproduce any step of that study, or maybe alter specific steps and again, reproduce it again, maybe with different, similar, or nominally the same data or pipelines. So, but how could we achieve that, right? And my guiding principles are simple. We should be greedy and we should be lazy. And by greedy, I mean that we should get as much as possible of all the data, all the information which we could get for the study, even if we think that maybe at this point it's not really necessary or relevant. And of course, we need to be lazy and do manually as little as possible, or as necessary to say. But okay, let me rephrase it so it appeals better to the audience. We should be thorough instead of greedy, right? So we not only should get as much as possible, but also know what we have done and when we have done it and how we have done it, right? And instead of lazy, we should be just efficient, right? Again, we should do manually as little as possible, but achieve ideally more than we originally even planned. So another principle which I will used throughout the talk, but also you've heard about maybe many, many times, is Pareto principle, right? And overall, it emphasizes that, let me just read it, right? For many events, roughly 80% of effects come from 20% of the causes. And we could, let's say, bit standard development follows that principle that we will not immediately try to address 100% of use cases, but we'll address majority of the use cases. Uh, so we have a good coverage of the field. And that is reflected here. So BEATS tries to achieve 80% coverage by minimizing the effort, concentrating the effort on doing what is necessary to achieve those 80%. And if you look at Pareto principle, it manifests it so many ways throughout many, many disciplines. And I also like visualization when it's presented as the iceberg, right? Iceberg is kind of really good demonstration of many, many aspects in the science. You could even take it as what we present as the results, typically in our papers, is just really, really tiny tip of an iceberg. But also the data which we actually collect is also just a slight bottom of it, because we collect relatively small amount of data and then we blow it up through our processing, pre-processing, and curation. So there is a huge bulk of it sits in the middle, but again, we typically share only a small portion of it. Okay, so I gave you the principles: be lazy, be thorough, and be greedy. Be thorough and be efficient, right? So, but many people also say, oh, reproducibility, it's like having a good recipe you follow, right? In my case, well, I've tried to follow some recipes and they came as a disaster, but in general, there should be a recipe how to accomplish, how to do the study in a reproducible way. So here is the beginning of the recipe and the ingredients of it. What we need for it, obviously, is humans. And I would say humans constitute 100% of the effort. So whatever we consider effort, it is human effort. Computers, nah, they don't have effort. We pay for the electricity, we buy computers, they don't really contribute to the effort. Us working with the computers, that is an effort. And also another ingredient which is somewhat overlooked is languages, right? So, and languages are actually, it is 100% of the results. If you look at what is the result shared, it's represented in some language. Classical result is what? Publication. And typically it was 100% human to human conversation, right? Where you essay what you've done, how you've done it, and that is the result, 100%. We kind of moving away from it and introduce additional more human to computer, more human computer mix in our results presentation now. Any data set which we collect and share, it is also a result, right? And it's represented usually not just random stream of bytes, it's represented in some form, in some file format, in some standard, and that is also the language, right? So language is actually of paramount importance. So let me talk about languages just a little bit more. And front load of quick takeaways: human languages suck, right? Unless you're into poetry or literature and language is your primary tool, they are really, really deficient. And to attest to that, you should look at the efforts which are ongoing. Cognitive Atlas by Russ Poldrak, which is our collaborative project, who leads one of the collaborative projects of ReproNim. We haven't agreed even what terms we use, what do they mean? What is specific task? What is memory, right? So all those terms which appeared sometime in the literature in human to human conversations, they've got stuck in our language and we don't exactly know what they are. And if you go deeper into this wonderful ecosystem which we have, you could look at Interlex, or efforts by TRND1 group as well. They concentrate on providing semantical meaning to different terms which we are using, right? And the same term could have different meanings in different contexts. But of course, human languages are useful, and one of the really good uses for it is README files. README files is something what humans encounter when you arrive at any, let's say, repository online. You go through README, you read it, and it should give you a good overview of, for a human, like authors of README deliver message to you, and that's where human language is useful. But then if we look back at the articles, in principle, methods and results, there should be really low effort spent by collating the results and methods presentation because they are machine generated. They're produced by computers, and they are the best to know what was actually done to obtain those results. Such human generated by machine language is not unprecedented. FSL, since long time ago, they had little summary which you were supposed to cut and paste into your paper. fMRI prep now is shining with a really nice method section, right? Because it details it for humans with all the citations. So that's kind of the goal, to have this machine generated human language, but also maybe supplemented with computer readable form, which would describe how those methods, what methods were used and how results were obtained. And then there was this such aspect as human to computer language. And those are typically programming languages, right? I will not say which one is the best, you probably know, but I could postulate that best programming language is the one which minimizes percent effort. It minimizes amount of work we need to do to accomplish the goal, to make computer sweat, waste electricity, use electricity to produce useful results. Here we go. But I also want to say that there is a corollary, that percent effort is minimized by using no programming language, right? So you say, what does he mean? What do you mean don't use programming language? Actually, if we look at the standards, right? If we have all our materials, results in standard form, then we could pretty much obliterate need for programming. And what is the problem with programming? It takes huge percent effort to write, test, maintain the program. Of course, many people just write and they don't care about test and maintain. But sometimes it ends up with junk in, junk out result. So it does take lots of effort to write a program. And another problem is any program typically creates a new language. And what I mean by language, how humans or us use the program and interact with it, and what does it produce as output, right? And that's why it takes effort to actually learn how to use a new program. Everybody who learned any new program knows that it's not that trivial. You need to read maybe documentation, figure out how it works. Of course, with time, you get proficient with it, but it does take effort. And programs typically have difficulty talking to other programs, right? So typically, it requires additional effort to create some kind of adapter or pipeline which will make two programs communicate with other. And that was one of the goals of NiPipe developed by TRND2 and others, to make pipelines which interface to many different programs which have their own language, right? And NiPipe is pretty much a Babel of programs which are used in neuroimaging, because it standardizes how you talk to them. Okay, so standards are out there to minimize this percent effort for any interactions between computers and humans and between computers themselves. That's why my recommendation would be to reuse and contribute to existing programs. So don't waste your effort to start new programs, but rather contribute to one or many. And you might say that, well, it shouldn't be Yarek who gives this advice, because he did start quite a big number of programs. But if you check out, I am trying to not create any new program. I am trying to contribute, fix, extend existing solutions. And that's how in ReproNim such solutions as Hudicon and ReproNim came about, QDConf existed before we even approached it. It was developed by our collaborators and members of ReproNim team, but it existed. Instead of reinventing the wheel and creating yet another new glorious one, we just adopted it. And that goes through many efforts. In IDM, we are TRND1 tries to integrate with bits nowadays. So we are trying to reuse and contribute instead of reinventing it something new and better. But also, to minimize such effort, we need to make programs operate on data and produce data in standard form. That's why adhering to standards such as bits, bits for derivatives, and more exciting development, which maybe not that many people know, is bits models and such solution, what is it, fitlins. It's really exciting because then with a minimal standard form specification for your analysis, you could just feed it to the program and it would do it. So, but also in addition, of course, we have an IDM to describe results in standard form and hierarchical event descriptors effort where they're trying to standardize how to describe events in the study. And on the bottom of all of that is more standard file formats pretty much, which describe just really basic. It's like, what is it? Standard of letters or words or grammar of your language, right? JSON, YAML, DICOM, NIFTY. Those are all used in the higher level standards such as bits and IDM. And then another aspect is to make programs or use programs which talk the standard interfaces, such as bits apps. So you could give it any bits data set and it already knows how to work on it. ABC apps of Brain Life, boutiques, flywheel gear. So there is these standardized interfaces, and when we develop or adopt a program, we should just make that program talk or participate in one of those initiatives and talk to others in standard interface form. And again, it's really important to contribute to development of standards. As I mentioned, BIT's purpose is to have 80% coverage of the field in terms of studies. So, and everybody or nobody is special, but everybody sometimes have some nuisances which are not covered by this 80%. And the same goes for software. Many people find that, oh, it doesn't do what I need, so I better create a new one. And then, of course, it becomes high effort. It's much easier to contribute to development of software and standards than to create a new one. So to minimize your effort, actually look into contributing to existing standards and software. And of course, this development will minimize overall effort to produce results in a standard form, so they could be reused with the minimal effort to produce new results. So it's recursive effect, right? Because results needs to come out also in the standard form, which would be consumed by the next program. Okay, let me just stop language rant. And the main takeaway is embrace standards at different levels for the data, for interfaces. Those are really useful. So let's get back to our recipe of a study and extend it with two necessary. Next item on the any recipe is steps, right? So in those steps, we need to do what? We need to plan the study ahead, right? And then humans and computers together, we do collection and processing. That's pretty much high-level recipe of any study which you would find there. But what happens now is that current dominant proportions of the recipe are quite skewed, not screwed, although that's probably not coincidence that those two words are together. So humans typically spend little effort to plan the study. Well, we submit a grant proposal, it is an effort, we do some pilot studies maybe, but altogether it's little effort for a study to happen. Then after we get to that road of a study, we spend a lot of effort to actually collect the data, do pre-processing, figure out how to do it actually, because we haven't planned for it ahead of time. Main disaster also could come if later somebody asks you to share the data and you forgot where it is, right? We all know about that. So what we really need to work on is to fix these proportions. And we need to plan the study ahead, spend lots of effort or more effort to plan the study ahead. So whenever we get to actual doing the study, that should be a really low percent effort. And as a result, that will actually prove Pareto principle wrong, right? Because our effort will be concentrated into producing those results, which majority of it will not be spent, let's say how it is now. I wrote a program to do the analysis and I spent so much effort that as for results, it was just minute portion of it, right? So we need to prove Pareto was wrong. And how do we do it? This is a more detailed steps for that recipe, which you could find on ReproNim 5 steps. And they go through pretty much all the aspects of any study in greater detail and recommend some ingredients of what you should put into your mix to make that study happen. And I think pretty much concentrating and going through this exercise of figuring out what should you use in your study, planning for it before actually doing it is important step. And if you look at the initial step, okay, look at the open brain consent form, that will prepare you to reduce the effort down the road. And another additional aspect, which is not really mentioned in 5 steps of ReproNim, is to prepare to be abused or used. And that doesn't mean by somebody else. It might mean by yourself, future you, especially if you move to another job and would no longer be allowed to access the data or resources you had access before. So you need to prepare yourself, think ahead, and that might make it more reproducible and open by design going forward. And also, in this planning, you should think about becoming more efficient or lazy and reuse work of others. Instead of, again, creating something new and flashy, see what solutions exist first and decide which ones you might use or you would use. And of course, it's not final decision, but it's something which will guide you through actually doing the study later on with clear idea in mind how you would do it. And of course, choose what to abuse, again, which software, and also possibly to contribute to. And 2 next topics I'll concentrate in greater detail, which would be choose resource data management platform or approach. And also, even if without choosing one, you should decide how you log or create a protocol of what you have done through the study. Maybe the RDM which you choose would provide that functionality natively. If not, then you better have clear notes, because those notes is what you will need to put somewhere in your method section, results, or in that README I've mentioned. But also another aspect is to collect richer data set. Okay, I'll talk about that more, and I just want to put another kind of in defense of pre-registration. Even if you pre-register not publicly, but go through pre-registration steps, which we've done in some of our studies, they are super useful as a checklist. Pretty much for all those 5 steps, they give you a checklist for knowing that your study in the future will go smoothly. But also in the future, you could pretty much use it as a regression test for your analysis. What have you done differently? Which might give you an idea also why results are different. And to prepare yourself for this road, there is lots of training materials. Some of them are available from ReproNim training website, in the webinars, which shared online. Also, brain hacks is our really great opportunity to train humans who work with you, such as students and postdocs, to talk to the computers more efficiently, to learn the standards, do a little bit of programming so you know how to program if you have to. Also, Data-led handbook, although it's data-led specific, but it's a great resource to train to talk to the computers via data-led lens if you decide to choose it. Okay, so let me concentrate now on plan ahead. So choose an RDM. What is research data management? Actually, that term is not really popular, but it includes all the concepts and the software and systems which through which how you go through your research process. So you could, of course, Google more, and I will not give details, but I will present you one of the research data management approaches, which is YODA. And YODA stands for Yoda's Organigram on Data Analysis. So it's recursive definition as was requested by Matteo Visconti. Matteo Maria Visconti di Oleggio Castello. Here we go. That's his full name. I think I hope I didn't screw up. So what are YODA principles? They're quite simple, and there is only a few of them. Use well-defined portable computational environments to compute analysis results. What does it mean is that we need a way to abstract computing environments so we could know what is inside of them. They're well-defined, how they came about, but also they should be portable. So we could do analysis here and there at different, across different heterogeneous infrastructure. Next aspect is exhaustively track all analysis inputs in the same version control system or some kind of system as the computed results, including all your input data, custom analysis code, and scripts, required computational environments. And then structure your study elements so they become modules. So you could take that module, which again includes all the data in analysis code and scripts and environments, and use it maybe in another study, right? So they become, again, portable and segregatable from the rest of the study. If you want to know more, and invite you to visit our poster from HBM 2018, I think, which has more details, but I'll guide you through some of them here. So what is YODA's layout? Well, that's prototypical or a hypothetical or actually used in many studies now, layout of how to organize your files in the file system. So not too far from what BIDS is, right? It's some kind of convention how to organize your results, because data is result of acquisition, right? It's already a result in the files. YODA doesn't instruct you really how to do it, how to name it, but that's one of the potential ways. And what matters here is that these external links here, that's the pointer to a module, right? In our case, we organize them one way. It could be organized different ways. But what is important that they should be independent. It could be a directory, but then you need to provision somehow just a directory, provision somehow to reuse so you could keep track of it. Okay, and with such organization, you could create the hierarchy of these embeddable modules all the way to the paper. So like in this diagram, which is also created by Michael Hanke from our collaborative project DataLet, on which we are both PIs, paper is based on analysis, right? Analysis is based on some preprocessed data based on some raw data, and bits, that's why it's not really raw, is based on other raw data like DICOMs. So there is this hierarchy, and the good RDM would allow you for this composition and maintaining access when necessary to any particular component. Also, this figure includes that containers could be yet another data set, and we've created one for you, which is called ReproNim containers, which contains all many popular containerized computing environments in neuroimaging. So if you want to learn more about YODA principles on non-neuroimaging example, please go to the DataLet handbook, which is created by Michael and our ReproNim YODA master, Adina Wagner. Why ReproNim YODA master? Because she is also our ReproNim fellow. And you would say, but nobody really cares about this YODA Michiwoshi, right? Well, surprise, fMRI Prep, with the next release, actually, I don't remember if 2021 introduced, there will be a new mode to structure the outputs of fMRI Prep so they satisfy this requirement of nesting. So recommended way, actually from Yoda, upon recommendations of yours truly, I believe it's called now just bits, because standard bits also allows for, just 1 second. Sorry about that. So with the next fMRI prep version, it will be structured according to the Yoda. And again, if you want to learn more with more data-led perspective, uh, look no further than your handbook chapter on that. Okay, overall, either data-led or not, but I would recommend you to concentrate on figuring out what RDM to choose, and ideally adopt Yoda principles, even though maybe not with data-led, but in general, the self-containment, modularity, they are quite useful principles altogether. And while choosing RDM platform, ask those questions. Could it tell you what you've done to obtain specific results? Does it tell you how to get necessary data? So later on, you don't need to do archaeological expedition throughout your hard drives spread around. And also minimize percent effort to run desired steps, either rerun desired step as is or modified. And it should work well with existing analytical platforms, because theoretically data management systems shouldn't really enforce you to use specific way to do data analysis, but it should just assist you. And of course, extra feature, it should allow you to search for data and results, so you could find those other nominally similar data to use in your study. Okay, let's get back to plan ahead and aim to collect richer data set. What did they mean with that? We should plan ahead and automate collection of any relevant metadata in standard form. So what about automate? Why should we automate collection? Because any manual data entry and wrangling, it's introducing hard to trace or later fix data bugs. Sometimes it might be impossible, right? Because you wouldn't be able to track back what was the original data. And also it's really quite inefficient. So automation in turn facilitates all these human computer interactions, because we just make computers do what we need and obtain results in such a form that we could make computers do more or work more on that data. And with such, we shouldn't really automate by coding everything, right? Programming ourselves. We should use existing solutions of which there is growing number. And also we should look for longer term low percent effort effects. Sometimes we kind of succumb to desire, oh, this should be quick. I'll just do this quickly and I will be done. But reality shows that it's not exactly that, right? That it takes much more time. But also regarding relevant, we cannot collect all the possible data, but so there is a trade-off of what you collect and what you will end up using. But think about that later on, you might find data which you haven't collected useful, because maybe it would explain more variance. And that is like if you look into reproducibility and low power, usually noise is considered something static, right? So, oh, there is noise, done, right? So let's just get more subjects. So low samples, right? That's the problem. But in reality, you might not need many samples. You might need low noise. So if we figure out better ways to explain the noise of the data we collected, we reduce number of necessary samples we need to collect. So, and new explanations of noise pretty much emerge on a yearly basis. And also, have data doesn't mean that you need to analyze all of it. By collecting excessive amount of data, you might analyze first only the one which is relevant for you, but then based on adoption of new tools, you might analyze more. And also regarding standard form, I talked about languages a lot. So we should minimize percent effort in our human-computer interactions. So there are multiple prior webinars on languages. I would refer you to our ReproNim webinar series to discover more. And let me just jump ahead to the first aspect: plan ahead, collect DICOMs, not nifties and parrecs, because those do contain lots of relevant metadata, which might or might not, or a majority of it would not be relevant to your study. But what is more important, that you take DICOMs and automate conversion into bits datasets much more easier than if you just get your nifties or parrec or some other files from the scanner. And also from DICOMs, you might be able to extract additional metadata in the future if you found that you haven't collected it originally while preparing your nifties. But also, you might be able to reconvert if conversion tool was found to be buggy. Nothing is given by God. All those conversion tools are also created by humans, and there might be bugs. So I want to introduce you to our approach for collection or conversion of data straight from the scanner into bits datasets, which is a tandem of UDConf and ReproNim. UDConf is a tool which is really flexible, based on Python framework for conversion to establish your own custom conversion from DICOMs into arbitrary layout. That layout could be bits, and UDConf understands bits, knows some aspects of bits to produce better bits compliant data sets. It's based on DCM2NX of ReproNim guru Chris Warden. And what ReproIn is two pieces. First of all, it's a convention. It's a convention how to name your files or your sequences in the scanner console and how to organize them. And it's really low percent effort. So you don't need to invest lots of effort. You spend, what, 5-10 minutes maybe ahead of the entire study to just name your sequences according to ReproIn. And then we provide heuristic for UDConf, so you could convert all those DICOMs automatically into bits. And this is a brief demonstration of how it could look. So you could see that actually naming convention is really close to bits itself, and we allow for arbitrary entities to be added into those sequences. From that one, we collect data as DICOMs. Those directory names actually don't matter how they look like. And if you pass it through UDConf with ReproIn heuristic, you'll get a proper bits compliant data set. If you want to know more about it, just go to our prior webinar. And the reason going work to provide a helper script to streamline handling of multiple studies. The Dartmouth Brain Imaging Center, where we developed and deployed initially ReproIn, we collected over 40 or 50 studies. So by now we amassed amount of knowledge we should dump into heuristics. But also UDConf is not unique. There are other tools. Actually, Data-led Herney is more like ReproIn level convention or framework, which would allow you to streamline conversions. EasyBits is more human accessible, no programming required web UI where you dump DICOMs and then provide mapping. But there is also many other converters. What is important, ReproIn or not, adopt some tool to convert from your DICOMs into bits. And hopefully it would be as efficient as UDConf ReproIn. Another aspect which might come as a surprise is I would recommend to get your thorough hands on Phantom QA data. Why is that so? Because Phantom QA data could explain some variance in your data. Code name for this project could be ReproPhantom, although by the time when we ran the study, we didn't think about it. So here's another Repro term for you. And if you want to discover more details about it, please go to our F1000 publication. If it sounds really interesting, please get in touch. I'll recommend you as a reviewer. We still need few reviewers to fulfill the quota. So in a nutshell, we planned ahead somewhat for that study by the fact that our physicists and technologists they are really nice in collecting weekly QA data, right? Because we've got new scanner, we wanted to make sure that it works correctly. They've collected all the data. Because it was named according to reprint, we automatically converted to bits data set. That one is available from datasets.datalab.org. And because we also had all our collected data in this nice repro-unified hierarchy, we could just ask 3PIs, could we use your data? They said, for our study, they said, sure, and we knew where to find it. So we didn't have to go through random hard drives and sets of DICOMs to figure it out where it is. And here is other details, but for the purpose of time, I'll just skip forward. So why did we do it? First of all, when we collect phantom QA data, we are interested in overall scanner health and look at the outliers, right? So if some measurement goes away statistically significant, we know that scanner is operating somewhat suboptimally, we fix the problem and carry on, right? And we just consider, oh, this variance is noise, right? So that's what we have to live with. But the reality, which we discovered in our study, we could explain, what is it? It would be what, 0.8 correlation coefficient, 0.7 something, right? So R squared value of 50.53 to explain this signal to noise ratio anatomical images collected on the phantom based on the scanner parameters. And also seasonal variations weren't significant, which is kind of intriguing because we expected them to be. But let's say daytime of acquisition was, although majority of phantom scanner scans were done in the morning, but it's logical to assume that through the day, characteristics stabilize in comparison to the morning. But also such parameters, specific absorption rate, which is estimated by the scanner, right, given the weight and other parameters, apparently has huge influence on it. But then we went to the next step. We took phantom SNR on the nearby date and used it in addition to demographics of human participants to explain gray brain matter volume. In theory, phantom QA, and of course, R squared value is much lower here because we just took basic demographics, not that much information about participants. But surprising fact was that phantom SNR acquired on nearby date was a significant predictor for the amount of gray brain matter volume. So scanner phantom QA metrics could provide you a proxy measure of scanner operation, which you otherwise wouldn't be able to collect on the human participant data. So the important part, you better be doing QA anyway, right, in your scanner. So you just need to talk to your technicians to not discard it, but rather get your thorough hands on it and keep it along with your study. It's ultra low % effort because hopefully it's collected already, right? Uh, but it's impossible, it's infinity effort to recover it when it's deleted. So, and people consider phantom data is not useful for anything else besides QA. So I know already a few cases where, oh, yeah, we've removed all those. Who cares about them? And it's relatively small % effort to make use of it. Just compute SNR, take that SNR, add as a regressor into your model. Okay, so next aspect is to collect physiological data. And our code name for it, ReproPhys. And luckily, we don't need to do much because good people already working on that. And there is a project Phys2Bits, which allows you to streamline conversion of physiology data collected with BioPack or other instruments. And there is a nice poster you could find online. And also another Bits Physio, which takes physiological data recorded already in DICOMs and also allows you to streamline conversion. There is outstanding PR, which we should act upon to introduce it also to QDCon. So plan ahead, consider collecting physiological data. Benefits are known. Just go to Phys2Bits website and there is good amount of references. It also can improve the power of your studies if you reduce amount of unexplained variants, right? So again, maybe you will actually save time from collecting more samples because you'll have a better, clearer data. and tools, as I described, are available. It's relatively high percent effort at the moment to set up and do, but it pales in comparison to the other efforts which you might do if you just have noisy data, right? So it's really under consideration, and we hope that we could manage to streamline collection so we collect physiological data for majority of our studies at DBIC. So plan ahead. That's another project, codenamed ReproStim, raw audio and visual stimuli. So the idea is to collect all video and audio stimuli as presented to participant, on which we are working with Andrew Colonnelly. I saw him somewhere in the audience. He was there. And you would say, why would you do that? Let me jump first of all to the end that it is actually the way to assure 100% reproducible experiment stimulation at 0% effort, right? If you have video and audio as it was presented, not some SciPy version 2.3 or Psych Toolbox, and you need specific computer to make it presented. Here you have a video file, and you could present it with your favorite video player at worst, or maybe one script which you could reuse for many studies. So it gives you 100% reproducibility for exactly the same stimulation as in any other study. So concept is really simple, but also it's useful, could be useful for QA. Let's say, oh, I remember we had jitter, but we forgotten to make a record. Let me look through the videos. Also, it makes it possible now to take those collected data sets, which may be designed not for forward modeling with rich video stimuli, but if that forward modeling model works for rich stimuli, it better works for stupid ones and simple ones. And now you could take any study and do this forward modeling. And again, you could explain maybe low-level signal features which otherwise you wouldn't even dare to analyze. And the whole setup is pretty much there and working already. So what you need is just few video and audio splitters at the cost of $50, video audio grabber at the cost of maybe one scanner, participant session cost, which is around 400, I believe, for this capture, and that's it. We are working on the tools, and they're already working. They automatically collect separate files whenever you connect, disconnect, monitor, or change resolution, and give you nicely formatted file names. We are working on synchronizing acquisition box with all other boxes, so we could timeline it nicely and introduce QR stamps into the stimuli itself. So later on, you could just analyze the video and figure out exactly what time was on the stimuli box according to that one. And working on automated slicing into bits data set. Okay, another plan ahead item is repro events. The idea is to collect and automate events information consistent in a machine readable form. Unfortunately, there is no one library yet, right? So the target would be to develop a library to use within PsychoPipe, Psych Toolbox easily, which would produce these rich event descriptors, ideally with hierarchical event descriptors standard. So later on, people could just take those event files and do some additional analysis which you might have not envisioned. But there is a big number of scripts which you could look up online, let's say one of them from Matteo, which with little percent effort, you could just create those events files from your stimulation scripts. Okay, so plan ahead summary, 80%, and I hope that was 80% of the talk as well. So if you plan ahead, and so far whatever I outlined is actually planning, right? It's not exactly doing it. It's choosing the technologies which you would use and training your personnel and yourself how to use them. So let's just jump into the remaining 20%, reproducible execution. So with this planning and choosing the languages instead of creating one with programming, it becomes more feasible and to automate it and also extract later knowledge how things were done. So the ultimate do it consists of pretty much just 4 steps, right? So data we talked about, it could be automated greatly. Quality assurance, there are applications which already do it for you. You just need to spend low percent effort on actually looking at the results of what they produce. Pre-processing, Such great tools as fMRI Prep, CPAC, they're out there to help you. And then analysis, right? Again, such tools as CPAC and now Fitlins and many others are blooming, which again, given that you can make it talk in standard form between all those steps, this is 4 steps you need to do. And that's an example. That was just random, pretty much web page which I found while looking for something else. I don't even remember what I was looked for, but I kind of got sympathetic to this one because even though not targeting reproducibility, and it was done last modified 2 years ago, it's just a README, as I described to you, for humans, which goes through basic steps for experimenters, right? Transfer the data, run HUDconf, run MRI-QC, fMRI prep, convert those events files. With the repro events, you wouldn't do it, and run the analysis, right? So if you say that I've lied, that, oh, you just need 4 steps, it's not true, right? So the entire study is really 4 steps. So what we need to do really is to automate them and at minimal effort use language which all the tools know, right? And then we just need to work on publication composition, which is ideally should also be automated as much as possible, right? By tuning prior stages to produce publication quality graphs. And fMRI prep, let's say, it already gives you the method section or big portion of it, right? So just keep in mind that everything might need to be repeated. So your RDM or your approach should allow for, oh, I want to redo the entire thing, right? And pipelining is great, but it can be tricky to write your own pipeline. That's why modularizing to these 4 steps and using pre-crafted pipelines from experts, such as MRI-QC and fMRI Prep and CPAC, all of them use NiPipe underneath. They are pipelines, but you take big piece and stick it into your small pipeline of 4 steps, and you're done, right? So you could create ad hoc pipeline in your simple script where you don't need to do much of programming. And containers can help to collaborate, scale, and develop analysis at each of those steps. As such, I just want to present you with one simple prototypical approach, how you would do it according to Yoda principles with ReproNim containers. In this case, we run bits MRI-QC container. And for that purpose, we use data-led containers run. By this point, by the point of data-led containers run, we didn't even get any data. And because we use data-led underneath and specify that input is source data, and we specified which container to use, it will do everything necessary to fetch the data, fetch the container, run the analysis, and save it back into Git. So at the end, you could ask the same tools which you hopefully know, git log, what has happened, and how that step was done. If you care to rerun that step, you just use data-led rerun, and you're done. This runs locally on your computer in a single, if your, let's say, fMRI prep would scale to multiple cores. But let's say you want to scale across multiple participants and run it maybe somewhere on the remote resource. For that, we have developed ReproNim. And with ReproNim, you could submit, similar to data-led run or containers run, you could use ReproNim run. And that one will ensure that you have the data for analysis at the resource where you want to compute. And then we'll data-led save and fetch all the results locally. If you want to discover more about the spectrum of how you could execute from bash through simple containers, through data-led, and to ReproNim, I would advise you to go and listen to a prior webinar I gave. And that's the end. And I'm right on time with 2 minutes to spare for questions.
Thank you, Yarek. Any questions out there? Well, while we get to questions, I just want to be mindful of the time. I just want to make 2 little quick announcements. January 1st would be the next first Friday of the month. We're not going to do it on New Year's Day. We will delay that one till Friday, January 8th. So it will be the second Friday next month. and our TRD2 collaborator, Remy Gao, will be here presenting on COBIDAS because writing methods is too important and boring to let humans do it. Again, kind of resonating with some of Yarek's points here is to let the computers write your methods sections and document what you've done. Okay, with that announcement, does anyone want to dare ask a question either in the chat or by carefully unmuting yourself?
Okay, there
It
is
was
a
completely
comment from
clear.
JB I could talk about,
Okay. Oh
since
yeah.
nobody dares. JB, there is a danger when noise is actually inter-participants variability. The former is to be reduced, not the latter, if we want our results to be generalizable on other cohorts. Exactly right, right? And the problem now is that we don't know what part of that noise is actually inter-subject, inter-participant variability or scanner noise because of not accounting for it, right, across different scanning sessions. By reducing scanner noise component, we know how much of inter-participant variability there is, and then we can easier account for it in other studies.
Yeah, for sure. And I guess scanner noise is temporal scanner noise, like you mean things like a change in the scanner temporarily, right?
Right. Yeah, and scanners, they fluctuate. Now we are collecting also humidity and temperature in the scanner room. It's exciting. It's exciting when we try to use it. Unfortunately, nobody scans these days because of the you know what, right? Okay, and there was a question about handbook, I guess. So let me just direct you. Handbookdatala.org. It has PDF, it has HTML. So everything there, I probably will not dare to send current version because it gets improved every day. And you could download PDF, HTML, or EPUB version for your own needs. By the way, based on this handbook, Sam Nastasi, who is our ReproNim fellow as well, created really wonderful Princeton neuroimaging handbook. So maybe I've forgotten to mention it. I should have done it. So you could see a similarity, but in general, it's also based on, and that one also goes through ReproIn and how they agreed to do MRI QCF, MRI prep. So again, number of steps is actually quite small on which to concentrate to make your execution reproducible. Just collect more data, adhere to the standards.
Okay. I think I will take this. Oh, there's one more question there in the chat.
How much time should be spent writing comments in code versus creating an accompanying wiki-like documentation? The problem with wiki-like documentation, or any documentation for that sake, that it gets outdated. So documentation is great and it must be there, like you could see handbook, but it needs to be, it shouldn't replace the comments in the code, let's put it this way, right? So comments in the code primarily for you or anybody else later on to figure out what code is supposed to do. Then there are interfaces, right? So whenever you --help, it should give you a nice interface. That one ideally should be part of your auto-generated documentation. So again, not wiki, but automatically generated from the code into documentation. The same goes for the man pages. The same goes for anything which should be coming from code. And then you go and write your wonderful handbook where you go through the steps at the higher level, giving examples. And the ideal handbook will be re-executable. Like data-led handbook examples, all you see, they could be re-executed and new output would be pasted into the handbook to render a new version. And we would spot whenever, oh, syntax changed. I hope that answers the question.
Great. Okay, and so you know how to contact us through the ReproNim website, through the Twitter, through email lists, and so any other questions, please feel free to reach out to us, and we will get in touch with you and try to help. So thank you for spending your hour with us, and we look forward to seeing you in 1 month plus 1 week, January 8th. Thanks all.